In this video, we're going to talk about thinking like an economist. So we're going to think about kind of how economists approach problems, how we think about understanding human behavior. The most basic thing that we're going to do is use the scientific method. So we're going to be thinking about something that we want to explain. We're going to be thinking about some potential explanations for behavior that we observe. We're going to think about testing whether or not our hypothesis explains the behavior or whether it doesn't. And if it doesn't explain the behavior, then we're going to think about changing our hypothesis. So we're going to use that scientific method, very similar to what you would do in a hard science. One of the things that we need to talk about is that we're going to be making assumptions. So in terms of how we approach understanding human behavior, the way that we need to start is we need to make assumptions to simplify the problem. So economists a lot of times are criticized for making assumptions, but assumptions are made in all different disciplines. So if let's suppose that we were talking about a physics problem and we were trying to calculate the amount of time that it would take for this pen, if I drop it, to hit the floor, then what we would do if we were going to calculate that using physics is we would make the simplifying assumption that it's dropped in a vacuum. If we make that assumption, then it becomes a much more easy problem to figure out. If we don't make that assumption, then we have to figure out the effect that wind resistance is going to have on this pen and factor that in. And that is a very complicated process. It depends on the shape of the pen. It depends on things like the air temperature. It depends on the humidity. It depends on the exact way that I drop this pen. And so if we assume that it's in a vacuum, we can ignore a whole bunch of that stuff and it becomes simpler. So that's what we're going to do, is we're going to think about making simplifying assumptions. So let's talk about the use of economic models. So you have used models before in your early education, and you'll continue to use them throughout your education. An example of a model that you've used before might be let's suppose that at some point when you're probably in grade school, somebody has shown you a picture of the sun shining down on grass and then a cow eating the grass. And that's designed to get you to understand how energy gets from the sun into that cow. And it's a simplification of reality, right? It's something that we can show to a small kid, and they're able to kind of grasp what's going on, at least in a general sense. But that simple model ignores a very complex set of processes that are going on there. If we think about the sun shining down on the grass and the grass growing, then we're ignoring photosynthesis, and we're ignoring a whole bunch of things about the sun and how the sun gets through the atmosphere, and then the cow eats the grass, and we're ignoring digestion and all of the complex processes that are going on into the cow to convert that food into energy. But it's a good place to start. So in terms of what we're going to do, we're going to be thinking about lots of different models. We're going to start with very simple models. And it's at first going to feel to you like this is too simple. I will have students in a face-to-face class raise their hand and say, well, but wait, things aren't that simple. Things are more complex. And what I always tell students is to enjoy the simplicity. Things will get more complex as we move through this. But at the beginning, let it be simple. Enjoy the fact that it's simple. Even though your brain's going to want to say, but wait, it's not that simple. It'll get a little bit more complicated. So let's start by thinking about a very simple model that we use in economics, and that's going to be what we call the circular flow diagram. So when we look at the circular flow diagram, that we're going to represent households over here with a little box. And then over here we're going to represent businesses, or what we're going to call firms. And there's no reason, don't infer anything about the fact that I drew that box a little bit bigger. That's an accident. So we've got all the households represented over here. We've got all the firms represented over here. And we're going to have a circle up here that we are going to use to represent the market for goods and services. Market for goods and services. So this is where you go if you want to buy a pizza, or you want to buy a new pair of shoes, or you want to buy a car. Okay? And the firms are the ones that are making all of those goods and services. The households are buying them. Down here, let's put the market for inputs. Some textbooks call this the market for the factors of production. The inputs are just the things like land, labor, capital, all of that stuff that the firms use to produce the goods and services. So the households, let's just think about this as labor. That's the easiest one to think about. It's the households that own the labor and sell it to the firms. So let's start with our market for goods and services. So the goods and services go from the firms to this market. So these are the goods and services. And they go to the households through that market. So again, these are the goods and services. The household pays for those goods and services with dollars. So here are our dollars. When households are buying goods and services, we call that expenditure. The number of dollars they spend, we call expenditure. Those dollars go into the firms. So when the dollars are going into the firms, we call that revenue. So households buy goods and services from the firms. So the goods and services are going this direction and the dollars are going this direction. If we think about this market for inputs, then the inputs come from the households into the firms. So these are things like labor and land and capital. Those things are owned by the households. And they go into the firms. These are the inputs. These are the factors of production, those land, labor, capital. So I'm going to say labor, etc. And the firms buy those. So the firms are buying the inputs and they're paying wages, rent if they're renting land, profits go to the households. And so the dollars are coming, these are dollars right here, the dollars are coming into the households, that's income. So in this market for inputs, the inputs are coming from the households into the firms, and the firms are paying for them with dollars, and those dollars are the income of the households. So this circular flow diagram is a good way of getting kind of a grip on how a basic economy works. It helps us understand that dollars are flowing circularly. The households take their income and spend it on goods and services, which becomes revenue for the firms. And the firms are using that revenue to pay wages and pay rent and pay profits for the inputs, and that goes into the households. Our goods and services are going in that direction. Our inputs are going in this direction. So it's a nice simple way to start understanding how an economy works. It ignores several things. So we don't have in here any government. So the number of dollars that households spend on goods and services, not all of those dollars go as revenue into the firms. Some of them go as taxes into the government. So if we wanted to make this more realistic, we could include a government. We don't have any other countries. So if you're a household, you don't have to just buy from firms in your country. You can buy from firms in other countries. We don't have that in here. So we can make it more complex, but we don't need to. This is a good place to start to understand how dollars flow and how goods and services and inputs flow in an economy. So that's an example of a simple model. We can also talk about another model that we're going to be thinking about, and that's going to be what we call a production possibilities frontier. So a production possibilities frontier, I'm going to abbreviate PPF. PPF, production possibilities frontier. What a production possibility frontier shows us is going to be all the possible combinations of output that an economy can produce given its inputs and given its technology. So given what the country has to work with, inputs and technology, the PPF shows what it's capable of producing. So if we were to draw a picture of a PPF, let's make life very simple, and let's pretend like there are only two goods that are going to be produced. Let's suppose we've got an economy in which there are only cars that are being produced and an economy in which there are only cars and computers. Those are the only two goods. So we need to decide how much cars to produce and how many computers to produce. Don't think about what's being used to produce computers or cars. Don't think to yourself, well, but it can't be that simple, because if you've got workers, then they have to eat, and so we would have to have food being produced. Don't make it complex. Enjoy the simplicity. Pretend as if we don't have to worry about tools or food or anything like that. Let's pretend that if we use all of the resources in this economy to produce computers, let's pretend that we can produce 3,000. And let's suppose that if we produce only cars, we can produce 1,000. Don't worry about the fact that my scale here is not to scale on the horizontal axis. We're not worried about that. Let's draw a production possibilities frontier. Typically, our production possibilities frontier is going to look like this. It's going to be bowed out. It's going to be curved like that. And what this production possibilities frontier, so this thing is what we would call a PPF. This production possibilities frontier shows us all of the possible combinations of computers and cars that we can produce given the inputs that we've got in this economy and given the technology. So if we look at a point like point A would be a possible production point. Let's suppose that point A would correspond to maybe, 2,200 computers and let's say, 600 cars. And so that's a possible production point. We would describe point A as being an efficient point. If we were to think about a point down in here like point B would be what we would call an inefficient point. It's a possible production point. We've got enough inputs and resources to produce point B, but we could produce more cars and computers than just point B. So we don't want to end up at a point inside the PPF. We could think about a point like point C. Point C would be what we would call an unattainable point. It's outside our production possibilities frontier. It's a point we don't have enough inputs or enough technology to actually produce. So let's think about starting at point A. Let's suppose that we want to produce 100 more cars than we're currently producing at point A. That means that we're going to move in this direction 100 cars. But notice that that would put us at a point outside of the production possibilities frontier. So if we're going to have 100 more cars, that means we have to have fewer computers. And so if we think about another point, let's call that point D. That's point D, where we've got now 100 more cars. Let's suppose that's down here at 700, but we've got fewer computers. Let's suppose that that means we can only produce 2,000 computers. So let's think about first the fact that the downward slope of this production possibilities frontier illustrates the fact that there's a trade-off. Society here faces a trade-off. If we want to produce more cars, that leaves us with fewer resources that we can use to produce computers. So, the downward slope shows us that we've got a trade-off. We can also do more than that. We can actually see what the opportunity cost of that 100 cars is. So what I want to do is I'm going to clear off that side of the board so that I can kind of do some work over there, and then we'll kind of think about what the opportunity cost looks like on this picture. So what we've got here is a movement from point A to point D, and we're getting 100 more cars. Let's extend that down. So the cost of 100 cars, what we're giving up to get that 100 cars, the cost is 200 computers. We can change that to see how much each car cost us. So if we said the cost of one car, if we want to turn that 100 into a 1, we've got to divide it by 100. But that means we also have to divide this by 100. So that says that the cost of each car is 2 computers. Now let's go back here and look at what's going on in this picture. If we were to draw a little line between points A and point D, and we were to calculate the slope of that line, remember the slope is the rise over the run. Well, the rise, if we go from here down to there, that's 200 computers. And if we go over horizontally, that's 100 cars. So the slope between A and D is 200, the rise, over 100, which is equal to 2. Notice that the slope of the PPF right there is exactly equal to the opportunity cost of a car. So we get an important result here, and that is that the opportunity cost of the good on the horizontal axis is given by the slope of the production possibilities frontier. Okay? So the fact that the opportunity cost and the slope are the same is not a coincidence. The downward slope of this production possibilities frontier is showing us the opportunity cost of producing this good on the horizontal axis. Let's talk about the fact that the opportunity cost is not constant. So clearly, we've got a production possibilities frontier that looks like this. Notice that the slope of the PPF, if I look at the slope up here versus the slope down here versus the slope down here, it's not constant. What we see is that as we move in this direction, the slope is getting steeper and steeper and steeper. In absolute value, the slope is getting bigger. I know the slope is negative, but in absolute value, it's getting bigger and bigger and bigger. And what that means is the opportunity cost of a car is not constant. It actually increases as we produce more and more cars. So one important thing that we'll be thinking about, especially in the next chapter, is we'll be thinking about what can cause the opportunity cost to increase. This is what we call an increasing cost production possibilities frontier. We could have what we call a constant cost production possibilities frontier. That's a linear production possibilities frontier. Turns out that what causes a PPF to be curved versus being linear is that the inputs are specialized. Notice we've got cars and computers. The inputs that would be used to produce cars are going to be different than the inputs that are used to produce computers. And the result of that is that the production possibility frontier is bowed out or curved like that. If the inputs that are used to produce this good and the inputs used to produce that good are the same, if they are not specialized, then our production possibilities frontier is going to be linear. You can see that the slope is constant, so the opportunity cost of the good on the horizontal axis does not change. So if we had something like tables and chairs, that would be an example of two goods that use the same inputs and the same technology. And so in that case, the inputs are not specialized. The production possibility frontier is linear. Let's finish up this section by noticing that the production possibilities frontier can shift. If we had a change in technology, then our PPF could shift out, say, in that direction. Or if we had a PPF, so let's suppose our technology changed so that computer production, we could produce more computers than before, it could shift out in that direction. Or it could shift out in both directions. So the production possibilities frontier can change. Depends on if our inputs change or if our technology changes. If you look at the rest of the chapter, what you'll see is that there's a discussion of the difference between microeconomics and macroeconomics. I talked about that in the first video. There's a little bit of a discussion about what economists do. Lots of economists work in Washington, and the book kind of describes some of the things that they work on. The book also talks a little bit about the difference between a positive statement, a positive economic statement, and a normative statement. I think that's something that's really easy to understand if you're looking at the book. Let's talk just briefly about it. A positive economic statement is a statement about how the world is. A normative economic statement is a statement about how the world should be. So if I were to say this statement, the minimum wage creates unemployment, that is a positive statement. It's a statement about how the world works. It doesn't have to be true. Turns out that is a true statement. But it's testable. That's the way you judge whether or not a statement is a positive statement or a normative statement. If it's testable, it's a positive statement. We can test whether or not raising the minimum wage or adding a minimum wage where one didn't exist before, we can test to see whether or not that creates unemployment. If I were to say, we should have a minimum wage. Well, that's a normative statement. That's a statement about how I believe the world should be. Okay? So your book talks about that. Typically, normative statements have to do with your opinions about what you think should happen, and positive statements are about how things actually work. And again, the positive statement could be wrong. It doesn't have to be a true statement, it just has to be testable. So I think that's something that you can look at in the book. So what we're going to do in our next video is we're going to talk more about production possibilities frontier, and we're going to talk about that principle that trade can lead to gains for people, that trade is not a zero-sum game. So I will see you in the next video.